Welcome back. In this section, we are going to talk about one of the main components of the business vault, which is the point-in-time tables. The primary usage of it is to make the querying the data out of the data vault easier, and therefore to increase the query performance. A point-in-time table is a modified satellite that helps when we need to query the data from a hub that has multiple satellites. So look at the sample. We have a customer hub which is connected to different satellite tables that consist attributes about customer name, relevant contact information, and the address details. As we discussed earlier, a hub can have multiple satellites based on several reasons. Mostly it is suggested that to split the data among the different satellites by source, data type, and the rate of change. In our sample, we can guess that a customer phone number probably changed more often than her name. And when there is a multiple change in the phone number and the rest of the attributes did not change, then we don't need to want to load entire row into satellite table each time. So by separating these attributes by rate of change, we'll reduce the overall disk space and the query performance will be better if there are fewer rows in those satellite tables. In the right side, we can see the data inside of the satellite tables. I just set up one descriptive column and hash key value and the load date instead of build up all attributes from the relevant satellites in order to make our example very simple. In the name satellite, we see the customer Emma with the specific customer ID 1000 and the load date shows when the data is loaded from the source system. Then in address satellite, we see that the Emma was living in different cities in different point in times. First, she was living in Los Angeles, then she moved to New York. And the last satellite includes the contact information and shows that her phone number is also changed over time. So now the critical points came up in here. If an end user asks a question that where Emma was living and what was her phone number in a specific point in time, how we could get a consistent result from all these tables while they all have different load dates. Let's understand better in a visual way. In here, the graphic represents the different versions of an attribute for a specific business key over time. For example, first row shows that we assigned version 1 for the name of Emma and the name never changed over the time. Beginning from 1st of January till an unlimited timeline, still the name is the same. Then we see the second row for the address satellite and it shows that from the 1st to 3rd of January, she was living in Los Angeles, then she moved to New York. And in the last row, we also see that from 2nd to 5th of January, she was using her first phone number, then changed on the 5th of January. You may notice in here we have different versions of each attribute for a specific point in time. In order to get correct information, we need to align in a consistent version of a data. Before discussing the methodologies that would help us to find out aligned version of data, we need to determine from which aspect we will look at the data. Do we need to do reporting on current point of view or historical? In here, business make the decision. In beginning of data warehouse projects, we need to sit down together with the business and data owners and understand their reporting requirements. They might be interested either the latest version of data or the historical perspective. For example, when we look at our example, business might be interested on the latest information, and the reason behind is sometimes historical view does not contribute any reporting value. For example, you work as a business analyst in Netflix and your customer changed his subscription from Gold member to Premium, then this information is very critical and needed from the reporting perspective. But if your customer updated his telephone number, you might not be interested old phone number or old address because it will not bring any business value. As a business analyst, you can report each month as how many customers move between different membership types from Gold to Premium or Silver. But reporting on how many customers changed their phone number would not bring any value to your business, or you find out that one of your customers did not pay the subscription fees in 6 months and you want to send a notice to his postal address and during this time he changed his address. So even the issue is happened in the past, you don't request and send a notice to his older address. Independent from the reporting date, the current address information is helpful in here. So it shows that report owner or business make the decision on how they are going to look at the data, either current or historical way. In here, when we would like to get current view, we need to access New York as a city and 999 and 111 as a phone number. This will usually require some form of nested subquery. So we calculate the latest load date from address satellite in a subquery and join with the hub. So we access the latest city where she was living. If you want to include the data from one or other satellites, the query gets a bit more complicated. So we need to add additional clauses for every additional satellite table accessed. And one of the important points in here is we use max load date to find out the latest version of a record. But as we already know that the load date is a field that presents when the data is loaded from the source system, so it doesn't have any business meaning. And these date fields cannot be considered also for reporting purposes. Therefore, in real BI projects, you need to contact with system owner or business to identify which date column has meaning from the business perspective and provides the latest or historical version of data. Most often, the date column has been updated in the source tables gives an identification on that. Now imagine we need a historical data from a point in time. You need to get a consistent load date from each satellite that was valid during a specific time period. The SQL now gets longer and more complicated. The query now looks like this. We added additional rows to each nested query that allows us to enter different reporting date. So we again find a max load date but lesser than the requested query time. In both approaches, we need to create complex queries in order to identify correct load date for each satellite. In here, point-in-time table will help us to simplify the query by storing the most recent load date for every satellite and so for every business key. Point-in-time tables are loaded from source satellite tables and include the relevant hash key of connected hub, which is the hash key customer ID, load date of the point-in-time table, and the maximum load dates of each attribute out of the satellites. So look at the behavior of it. 1st of January, we have received a record in the name and address satellite. So we get the maximum load date record from source satellites and write into the point-in-time table. You see in here contact information is null because there is not any record received yet. Then 2nd of January, we again load the max date from satellites, but the max date is the same for the name and address tables because there is not any new record added. But we received a new insert in contact satellite and it's also maximum date. Then we insert this information into point-in-time table. Then 3rd of January, we get a new record in address table as Emma changed her city and therefore we have a new load date. And we inserted latest load date information to point-in-time table and rest of the columns remain the same. Then 4th of January, no inserts in satellite tables, but please take attention in here. We still load the point-in-time table from satellites with the maximum load date. But because there is not any record received, maximum load dates in the point-in-time table remains the same. Then 5th of January, we have a new record in the contact table and we insert the new maximum load date information into the point-in-time table. So now look at the table in detail and see how we are going to use it in reporting. Assume that today is the 6th of January and I would like to run my report for the 4th of January. So the current date and the reporting date is the different. First I select specific business key from hub table, which in here it is 1000. Then join with the point-in-time table and enter a reporting date. In here the load date of a point-in-time table will help me. So the load date is equal to 4th of January. Then this single record gives me the maximum load date information for each satellite attribute in specific point in time. So with this information, I will join the satellite tables and get the relevant value. And I will also access different versions of each satellite attribute for different reporting times. And we can see the detailed SQL statement in the right side also. We do not have subquery anymore in the query, but this logic will work only if we are loading the point-in-time table every day. If we do not load every day, then there will be gaps on the point-in-time table. In this scenario, we can either have a subquery, but at least we will have a single subquery in order to find the correct version of data, which means that we will find the maximum load date out of the point-in-time table, which is lesser than the reporting date. So we don't need to have multiple subqueries for each additional satellite. Or as a second option, we would add a valid-to column in order to put a time interval for each record by updating valid-to column with the latest load date information. And the valid-to column of the latest record will be updated by the maximal date December 9999. And that will make the life of user easier in respect to reporting, but on the other hand, it will increase the complexity on the ETL side. So in the last picture, we see the overall picture of our scenario. Point-in-time table is the part of the business vault. Therefore, from an implementation perspective, row and business vault should live in the same schema. And the point-in-time table is loaded after the row data vault is completed. And point-in-time table is created based on a hub or link table, which has multiple satellites. And as we already mentioned that they store only the hash key of the hub or link table and the load date of the corresponding satellite tables. It is also possible to add more computed attributes such as the hub business keys in that table. And the general idea is point-in-time tables make the easier of the querying out of the data vault and increase the performance.